If you're ready to unlock more better days, to take control of your health, to push past your limits and unleash your full potential, then you're in the right place. I'm your host, Dr. Jeremy Bettle. For over 2 decades, I've worked with elite athletes and high performers, helping them optimize their bodies, strengthen their minds, and recover from setbacks. Now I'm bringing that expertise to you through the Vitality Collective podcast. In each episode, we'll dive deep into the science, strategies, and real-world solutions you can apply right away. Whether it's enhancing your physical performance, avoiding or recovering from injury, sharpening your mental edge, or simply feeling your best every single day. With insights from top experts and thought leaders, this podcast is designed to help you take action, feel better, and live the life that you deserve. Welcome to the Vitality Collective podcast, where every day is vital. Today, I'm joined by my co-host, Michelle Bettle, my wife, co-founder, and longtime partner in this mission towards optimized wellness. In this episode, Michelle interviews me on a topic we've both been exploring deeply: brain health and how exercise plays a crucial role in keeping your brain sharp for life. We'll dive into how movement affects mood, memory, and focus, uncover the real science behind hormones like BDNF and IGF-1, and share what anyone at any age can do to protect their brain starting today. If you felt overwhelmed by all the wellness shoulds, this conversation will ground you in the simple, science-backed steps that matter the most. Let's get started. Welcome, everybody, to this episode of the Vitality Collective podcast. Today, I'm joined again by my wife and co-founder, Michelle Bettle. She is going to be interviewing me based on a series of talks that we did here in town on longevity, and a particular focus we put was on brain health. Today, Michelle's going to be asking me questions about exercise and your brain health. So this is really all of the things that are under your control to maximize the efficiency of your brain and to optimize your health and longevity when it comes to your brain. Welcome back, Michelle.
Thank you. I'm glad to be here.
Yeah, it's been since episode 1.
Yes, and here
Amazing.
we are, episode 16.
Episode 16. Yeah. 16 weeks of the Vitality Collective podcast.
Yes.
It's been unbelievable to produce and host this together.
Mm-hmm.
I think we're both learning a ton.
Yes.
Both about production and podcasting and just about the human body and human performance longevity.
Yes.
So we've been really fortunate to have some great experts on.
Yes. And I have been beside you for 20 years asking questions of you, of these experts.
Yeah.
So it feels kind of natural for me the camera part doesn't feel natural, but asking you questions feels natural.
Yes, I would agree with that. Well, where do you want to start?
So you work one-on-one with a lot of high achievers, and you're frequently drawing parallels between the pro athletes that you've worked with in the past and then the cognitive athletes, drawing those parallels to help people understand how the body supports the brain. Can you tell us more about that?
Yeah, so this was a point we just made to someone the other day. When we think about how we work with athletes, you're preparing for an event, right? So whenever we're preparing for an athlete, we have the event here. Everything we do in the lead up, we sleep, we eat, we train, watch video. Everything we do is to create an optimal performance state within the body and the brain for that event, or a big sales presentation, or a big conversation you've got to have, a big decision you've got to make. So we go through these processes out in the real world sort of unconsciously. We just think that we can show up to work and our brain's going to show up with us, right? And it's going to perform how it's going to perform. But we don't realize how much that our behaviors actually influence how the brain can perform, how the body can perform, and the connection between the two. So the parallel between high achievers, our cognitive athletes, and pro athletes are linear for me. Mm-hmm. All we're trying to do is maximize our body and our brain's performance for an event.
Mm-hmm. So it's all connected. Your body supports your brain.
Yes, it does, but it's not just connected, right? It's not like there's a wire running between them and it's just plugged into. Mm-hmm. It's one system.
The body, the brain, the mind, there's not a brain-body connection. It's all one system. The same blood supply, the nerves are coming from your brain to your body. The blood supply is circulating through the body and through the brain. It's all one system. And so I think that's really how we've got to start looking at the brain, is not as something that's connected to our body, but as something that is our body. Right? It literally is part of our physical being, and the mind sits within that whole concept.
So when you opened up the recent talk that we gave, you talked about brain health isn't just luck or genetics. Can you tell us more about that?
Yeah, I think recently we've got really caught up in the tests that we can do for the genes associated with Alzheimer's. So there's the ApoE4 gene, and depending on the variations that you present with, you can have a far elevated risk of developing Alzheimer's. And that's terrifying for people, right? And I think once we found that out, people sort of started thinking of it and seeing it as a bit of a death sentence. Like, this is something that's inevitable. But what we've found is that there are so many modifiable life factors that actually go into the development of Alzheimer's and dementia, that just because you see an elevated risk doesn't mean it's inevitable that you see elevated incidence. What that risk means is simply that you have less wiggle room than somebody else on the factors that are going to promote brain health.
Yes.
It is so important that if you've got elevated risk, you raise your lifestyle factors to match that.
Yes. And personally, that is one of my concerns. Alzheimer's and dementia runs in both sides of my family. So I know that I have to have my lifestyle a little more dialed in than maybe someone that doesn't have the family history, the risk that I do. So let's start with strength training. I think a lot of people mostly associate strength training with muscles. They don't necessarily associate it with memory. Can you tell us more about that?
Yeah, I think maybe before we get into strength training, let's sort of put some parameters around brain health and the things that we're sort of looking for here. So one huge component is energy availability to the brain. If we think about the energy demands for the brain weight makes up 2% of our body mass, but it actually makes up 25% of the energy usage. So it uses about 25% of the calories that we take in through our diet.
So it's very hungry.
Very, very hungry for energy. Consider the parallel there, that the muscular system, which we associate with fueling and all that sort of stuff, that's 30 to 40% of our body weight, and it uses about 25% of our calorie intake. So the equivalent of the brain, where the brain is only 2% of our body weight. So maintaining the energy demands there are a huge focus here for what we're going to talk about with regard to brain health. The other side of it is how are we actually protecting the neurons, creating connections between different parts of the brain, creating new brain cells. That's something that we were taught that couldn't happen, but actually happens very much in adulthood. And so there's sort of the physical structural parts of the brain, and then there's the energy systems part of the brain. And so we're going to talk about both today, and we're going to talk about, with each exercise modality, how it achieves both of those goals. Underpinning a lot of this stuff, particularly the energy availability, is our metabolic health.
Yes.
So our ability to manage glucose within the blood, essentially. What happens as we start getting into metabolic dysfunction and we start seeing insulin resistance, reduced sensitivity to insulin throughout our body? That not only affects the muscle tissue, it also affects the neuronal tissue. Now, because the primary energy supply for the brain is glucose, what we see is with insulin sensitivity, we actually limit our ability to take glucose up into the brain. If we can't get glucose into the brain cells, we put that neuronal cell in a really compromised position where it can't fuel its activity. So that slows down everything in the brain. It creates increased oxidative stress in the brain because the mitochondria start to get into dysfunction because they don't have the fuel that they need.
And mitochondria it's an energy system.
The mitochondria is the power plant, right? So that's the power plant for every cell in our body. They take the glucose and they convert it into ATP. ATP is the energy currency of our body. So the brain's going to use huge amounts of ATP in order to produce the functions that it needs to send all the signals to process the memories and everything else that it does for us. So there's a huge demand on getting glucose into the cell and being able to use it efficiently. So that's the primary part of our metabolic health that we're going to be focused on today, because we must be able to maintain that energy supply to the brain. And metabolic health is one of the primary factors in limiting that. So a lot of the exercise parts that we'll talk about will lean into that. So as we get back to then your question around strength training, there's a number of different factors here. So multiple different kinds. We hear a lot of talk recently on podcasts on the importance of strength training, but no one's ever really clear on what it is. So we've got traditional weight training, which is essentially heavy compound lifts, compound meaning multi-joint, things like squats and bench presses and deadlifts. And then we've got circuit training, right? So rather than doing a set, resting, doing another set, where we actually go from one exercise to the next, and then back to the start, right? And so we do that in a circuit. An example of circuit training would be like CrossFit, for example, right? So very continuous, going from exercise to exercise. Yeah.
And then when we talk about strength training, I think that a lot of people sort of past a certain age, when they hear weightlifting or strength training, weights, they just sort of tune out. I mean, I started lifting when I was the only woman in the gym.
Right.
I mean, 20 years ago, you did not see a woman my age lifting in the gym unless she was like a serious bodybuilder.
Right.
But now it's great because you see women of all ages in the gym doing all sorts of different stuff that's not just on the treadmill. So what we're talking about here is strength training for any age,
right,
any level. Like there is a level that you can start strength training at.
Yeah, and I think that's important because a lot of emphasis has been put on heavy weight training. And for somebody who has never lifted, we've got clients who are 85-year-old women. They are coming into the weight room for the first time in their life. So obviously we can't have them jump right to heavy deadlifts. What's important is that you start at your level. So this really is for anybody. We need to start with a preparatory phase where we prepare your body for the demands of heavier strength training further down the line. So what that means is we'll start and find imbalances and where you have certain weaknesses and maybe some pain. And we'll put you a program together to work you out of that pain cycle and to build that base where now you're symmetrical and you've got some basic core strength, joint strength, to now start layering in heavier lifts as your capacity improves. Where you might get hurt if you start going right into heavy weight training is we're going to exceed your capacity, and we're going to exceed it by a long way. So if we create that big gap between what you're capable of and what we're asking your body to do, this is where the weak spot in your kinetic chain, in your body, that's where that's going to break down. It's really important that with your program, we set you a program that's slightly above your capacity. We keep you in the program and start building you up to that new level. Once you get there and once that starts becoming easier, we stretch you again, right? A slight incremental improvement or increase, and we train you in that program to increase your capacity again. That way we know we're safely building you towards that heavier weight training.
Mm-hmm.
This can't be cheated. It can't be something where you jump levels. You have to earn the right to lift heavy. And I think that's really important to emphasize for people who are just starting, because it can be an intimidating thing and you definitely can get hurt. Mm-hmm. So really important part of strength training there is, how do we bring you on slowly?
So for someone that can't work directly with us, and as a Pilates teacher, I would like to make a Pilates plug here. It's a really great place to start, to sort of make a foundation for moving into weights.
Yeah. Mm-hmm. Yeah, I think that's such an important point, building that core strength and hip strength in order to be able to move into some more compound lifting. I think it's a really important point. Overall, if you're looking to start this program, it's very important that you are guided through weight training. So finding a trainer or an instructor at your gym who can guide you on this journey, and you need to interview that person. There are many, many ways to approach this, right? There's a ton of different philosophies, and there's a ton of different ways that we can argue over the tactics of how we do this. You need to find a person who resonates with you, but you also need to ask them, what's your plan? Do they have a strategy and a systematic way to work you towards your goals? That's what you have to ask them. And you have to be happy with their response, and find someone who their system, their strategy, it makes sense to you, right? If that resonates with you, then their system should give you the results that it says. You should be monitoring that. Are you getting closer to your goal? Whether it's improving your body composition, adding lean muscle, improving bone density. You can measure all of this. And so just make sure you're frequently checking in, making sure that you're doing the right things and working towards your goal. But that should be a really systematic thing.
So then let's get into now, what does lifting weights actually change the brain?
Great question. So there's a number of ways this can happen. Primarily, if we look at now the physical structures of the brain, one of the things that weight training does is it creates this chemical mix in the brain that's super important. There are a few compounds that we're going to talk about with every exercise modality. So we've got BDNF, brain-derived neurotropic factor. Not all that important, but you're going to hear it over and over again. So BDNF, super important. This is like the master chemical within the brain that has a whole host of functions. So it's created from a gene that promotes its growth. It's a protein. And the actions that it has in the brain include, neurogenesis, making new brain cells. Right, so it takes those neuronal stem cells and differentiates them into new brain cells. So we actually start building out more brain cells in areas like the hippocampus, in the prefrontal cortex, in order to improve our memory. Right, then we've got IGF-1, insulin-like growth factor 1.
And these are part of the chemical mix.
Exactly right. Yeah, yeah. And so what this one does, it's actually produced in the muscle cells.
Okay.
What we see is, under tension, with that mechanical stress and the damage that's happening within the muscles as we lift weights, we release IGF-1. It's there to help promote healing within the muscles, laying down of new protein, essentially helping us recover from the stress that we've put on the muscles.
And can I stop you for a second? When you talk about damage happening within the muscles, this is a good sort of damage. That's actually what happens when you lift weights. Is you have a little micro damage and then it repairs stronger. Is that accurate? Yeah,
that's exactly right. So our fibers sort of sit parallel to one another and overlap. And when we lift weights and put them under a lot of tension, we get some micro damage within that muscle cell. That's what creates the adaptation to get stronger. Because what happens is we've stressed the muscle to a new capacity, and we now have to come down and repair it to be able to withstand that level of work next time. So this is good damage. This is what that stretch looks like. This is what that just above your capacity looks like.
Okay. And so in this process, it releases this chemical mix.
Yes. So IGF-1 is released. And when IGF-1 is released, it will actually come into the bloodstream.
Okay.
and it will go up to the brain. So much like BDNF, it actually has some direct impacts, just like BDNF does. So new cells, protecting the cells that already exist.
Okay.
You know, this is a huge role of BDNF as well. It will actually stop the cells you already have from dying. Right.
Okay.
So huge impact. Once we start seeing IGF gets to the brain and causes another increased release of BDNF.
Okay.
So it really has this amplifying effect of the weight training. So that comes up and is a complementary factor, but then promotes more BDNF being released. From there, when we continue lifting, when we're done, in the 15 to 30 minutes post lifting, we see big increases in the release of growth hormone and testosterone. Again, both of these hormones come to the brain and have a direct impact in the exact same way that BDNF and IGF-1 do. Both of them create another big spike in BDNF.
And so does this happen with women too? Because you just said testosterone, and I know a lot of people think that testosterone is strictly a male hormone.
Right. Okay, we'll cover that real quick. No, testosterone is not a male hormone. It is the sort of male sex hormone, and that's sort of what we hear of these things as. But testosterone is actually produced in every woman. And it's actually produced in 4 times higher quantities as estrogen. Still lower than a man, but higher than estrogen. So every woman has testosterone. It is a critical hormone for men and for women. There are testosterone receptors in every cell in the body, including the brain. So brain health for women includes testosterone. So don't just think about this as a sort of menopausal sex hormone loss.
Right.
Testosterone, estrogen, progesterone, all critical for all other functions of the body. This is where women's health needs to catch up. Right. We need to understand the roles of these hormones throughout the body. These are systemic hormones. These aren't just about having kids for men or women.
And this is a whole other podcast on its own, which we've done with Dr. Kelly Casperson.
Yeah.
You can check. We'll put that in the show notes.
Yeah, that's an important one to understand the roles in a little more detail. And so yes, men and women get testosterone. Testosterone drives more growth hormone release.
Okay.
Growth hormone drives more IGF-1 release, this time from the liver.
And remind me what the growth hormone does again for the brain.
So growth hormone has a number of really interesting factors. Similar to BDNF. Okay. So proliferation of new brain cells, maintenance of existing brain cells. But the other thing it does is it facilitates the uptake of glucose.
Okay.
Right. We talked about that as being one of the key factors in promoting brain health is energy availability. So growth hormone, particularly when you sleep, actually helps replenish the energy systems of the brain. So helps to renew and refresh the mitochondria, helps take a lot of waste products out of the cells, and also helps glucose come into the cells and maintain that energy supply. And so it's such an important part of that chemical mix. Again, further increasing IGF-1, which further increases BDNF. And so you can see as we saturate the brain in these real, like, physical health promoting chemicals, and we do that day after day after day, we really start to see that direct line to how exercise, and in this case particularly strength training, promotes a healthy brain. So those are sort of some of the physical factors of how strength training affects the brain. But what we've also got to think about is the energy demands we're placing on the brain. How we increase our fitness, for example, or our strength, is we stress the metabolic system. So we create an increase in energy demand, and that forces our mitochondria to upregulate how much energy we can produce. So we get more mitochondria, and our mitochondria become more efficient. So as we place this huge demand on the brain, when we're coordinating these big whole body movements, and we're having to fire so many neurons to lift a heavy weight. We're having to coordinate every muscle, every single muscle in the body that's involved in that lift has to get fired by the brain in the right sequence with the right amount of force. So it takes a massive neuronal stress on the brain. Then we've got to think about how many different areas of the brain are involved in coordinating that. So now we're creating increased myelinated connections between different areas of the brain. So these were connections that weren't necessarily happening until you started this kind of training.
And is that why when you start a new program with a brand new exercise, it can seem so much harder, like the hardest thing you've ever done the first time you do it or the first set or two, but then by the third set or the next time you do it, it just feels so much easier.
Yeah, and that's especially like when you get somebody who's just starting weight training, or like you said, when you start that new program, primarily in that first 3 to 4 to 5 weeks, you get these huge gains in strength, and largely they're neurological. So it's your nervous system figuring out how to do the movement. So you become more efficient at performing that movement because your nervous system sort of gets rid of some of the redundancy, because it sort of throws the kitchen sink at it initially. And then it starts to pare back. Okay, this is exactly how we do that movement. And so that's sort of the other way that we benefit the brain here is cross connectivity. All right. So we've got new connections, but we've also upregulated the energy producing systems of the brain. So more mitochondrial density, more efficient mitochondria, and they actually allow us to have a more robust and faster firing brain. All of these chemical factors increase our myelination within the brain. So the myelin sheath, essentially the term is when neurons that fire together wire together. And what that means is we get a stronger and stronger connection down a set of neurons that repeatedly perform an action. So as we release growth hormone and testosterone and BDNF and IGF-1, they start increasing the myelination of all of these connections. That means faster neuronal nerve impulses, right? So we can fire the brain faster, send signals quicker, and it enhances our ability to consolidate memory. So we start, especially in the hippocampus, we really see a huge impact of BDNF. So we see big increases in things like executive function, in memory, in people who lift over time. And what we've found is that people who exercise have a larger hippocampus when we do the MRI studies than those who don't. So really physical benefits to your overall brain health and longevity. And one of the things that creates, and we'll talk about it a bit later, is this cognitive reserve that we'll see. So a brain that's more resilient to damage, physical damage, a brain that's more resilient to cognitive decline because it has different connections than someone who doesn't lift would see.
And so these hormonal effects, talk to me about how they affect your mood.
Yeah, so there's a number of ways that this can happen. So particularly when we start looking at the neurotransmitters that are released, and this will happen during sort of circuit training and high intensity work that we'll talk about in a minute. But we see big increases in things like norepinephrine, in serotonin, and dopamine. And they're much longer lasting effects. You know, we think about like eating chocolate or checking Instagram as being dopamine hits. And they're really, really big hits that last a couple of seconds and then they drop way below baseline. So you get this recoil effect. That's what makes you keep reaching for the phone.
Or the chocolate.
Right. Yeah.
Speaking from experience.
Right. And so just such an important part of that is we get the big dopamine spike, but it lasts, right? So these are longer lasting impacts. And a great way to start our day is to get these big neurochemical changes, these big boosts in dopamine and norepinephrine and serotonin, huge mood boosters going into the day. But also it helps us regulate cortisol. And so we start losing some of that stress response, and we're much better able to regulate our emotions as a result. Because what will happen is that we'll see an uptick in activity in the prefrontal cortex and a lowering of activity in the amygdala. And so we get less of that emotional reactivity.
And the amygdala is essentially the reptilian brain.
That's right. Yeah, that's where you're super emotional, super reactive, and it really sort of applies that fear and anxiety filter to the world.
Right.
So the information coming in now starts to be received in a very different way.
Okay. Yeah. So what we're talking about here, is that the runner's high?
Yeah, that's going to be a part of that. So that's the endorphin release that we'll get, and that's all a part of it.
So we've talked a little bit about it, but how does lifting weights help with focus and memory?
Well, so memory consolidation is huge. So we talked about the hippocampus a little bit. That's one of the centers where growth hormone, BDNF, IGF-1, testosterone have direct impact.
And that's those chemical mix that is released when you lift weights.
That's right.
Okay.
Yeah. So those factors have direct impact, particularly in this center of the brain. Okay. So this is highly associated with memory. So as we start creating new brain cells there, as we start protecting the existing brain cells, so we protect them from oxidative damage and cell death, we really start consolidating that structure and protecting the memory, essentially. So that all those myelinations that we were talking about, the stronger synaptic connection between brain cells, these are what create our memories. And so the more we can protect that region of the brain, the better our memory is going to be long term.
And then what about focus? How does lifting weights affect focus?
So that's one of the short term benefits.
Okay.
Right. So as we lift weights and we get these spikes in dopamine, norepinephrine,
Okay.
that is a huge acute spike in those neurotransmitters
Okay.
that allow us to really focus and dial in. So we see in the research big increases in all these markers of focus, attention, higher executive function, because of that mix of epinephrine, norepinephrine, and dopamine in the brain.
So for me personally, in the mornings, first thing I like to do is sort of have my focus time at the computer. So for my schedule, it would probably be better for me to lift before I do that in the mornings rather than at the end of the day at night.
Yeah, absolutely. And that'll really fit with your circadian rhythms as well. Right. So we want to be at night, we want to be starting to wind down into sleep. So we don't want to be too close to sleep with our workout. If we put it up here at the start, first of all, we start to clear some cortisol, which is huge. But we get these big increases in focus, attention, all this sort of stuff. If you ended your lift with some anaerobic work, some high intensity intervals that we'll talk about later, you'd really carry that into a highly focused period in the morning.
And then we also operate on sort of the good, better, best philosophy. So if you can't get your workout in the morning and you have to do it at night, it's better that you do your workout at night than not do it at all.
Yes.
Yeah.
Always move.
Yeah.
Right. There's no perfect in any of this, because we're not a lab, right? None of this happens like in an exercise science lab where we have to keep the conditions perfect and it has to match these perfect scenarios. Or we lose out on this 5% benefit. All of that's largely crap when it comes to the real world, how this actually impacts you. So always get your movement. Don't think because I said it's better to do it in the morning, then I just shouldn't do it. If that's when you can work out, that's when you work out.
Right.
Your body adapts to it. You will be able to get those benefits.
So then, do we need to lift heavy to get brain benefits?
So yes, heavier lifting is better for the brain. But again, just like we said before, don't dive right into heavyweight training, and don't think you're getting no benefits if you're not lifting heavy. Of course, you're getting some benefits. These things aren't an on-off switch, right? There's a gradient of improvement here. So increase over time, always move, you will be getting brain benefits. So that's the important thing to bear in mind here.
And personally, my granddad was in his late 90s, sharp as a tack till the day he died. And he lifted TVs in his 90s. He had a TV store, and I would always try to discourage him from lifting because, I didn't want him to get hurt. That's before we knew all this information. But he was sharp as a tack, and I think there was part of him that knew instinctively he needed to keep moving.
Yeah, absolutely. Yeah. Because I think we all recognize that when we move, we feel better.
Yeah.
Right? Your body feels better. All those aches and pains start to melt away.
And let's talk about energy utilization in the brain. So how do we optimize for energy efficiency?
Yeah, that's another great part of weight training. One of the key markers here is increased insulin sensitivity. So there's a couple of ways that exercises causes glucose to come into all the cells in the body, but particularly the brain. So we sense that demand for energy and we sense that depletion of glucose within the cells. And that signals different receptors without insulin to bring glucose into the cells. Okay. So now our insulin sensitivity doesn't matter so much because we're actually able to transport glucose without it. Lowering overall blood sugar is phenomenal for our metabolic health because it means that we need less insulin swirling around our system. The other thing is it creates increased insulin sensitivity within the cells. So rather than being resistant, which it has been, now we start to see insulin having a bigger impact. So again, it's sort of a double whammy effect here where we can passively take glucose into the cell, but we find insulin actually having a bigger impact on the cells. And so we're able to transport more glucose and maintain the energy supply. So this is one of the most important impacts acutely in the brain is that we can maintain energy supply better in people with metabolic dysfunction, high blood glucose and high insulin and insulin resistance.
Yeah.
So that's throughout the body.
And like pre-diabetic too.
That's what I'm talking about. Right. So that's a really good distinction. Thanks for that. So starting with metabolic dysfunction.
Yep.
Right. We're going to see elevated insulin and that will be ahead of elevated glucose.
Okay.
Right. So the markers for diabetes are what is your hemoglobin A1C, right? So that's your 3-month marker of your blood sugar.
Okay.
So your A1C will steadily increase. And once it crosses a certain threshold, we classify that as pre-diabetes.
Okay.
And once it passes another threshold, now that's diabetes.
Okay.
And so we see that increase. Again, it's not that it just goes along normal and then boom, you're pre-diabetic. We can monitor that increase. Ahead of that increase in A1C, we're going to see elevated insulin. Because as the cells start to become insulin resistant, and this is metabolic dysfunction before we get pre-diabetes, we need more and more and more insulin to force glucose into the cell.
Right.
Once that stops having its effect, now we start seeing blood sugar rise. So as we see blood sugar now start to come up and we've got high insulin, we've got that insulin resistance within the body and we're now really limited in our capacity to get glucose into the cell, which is what creates these energy crises within the brain. And so huge benefit here of strength training in increasing that insulin sensitivity and reducing the impact of metabolic dysfunction and diabetes on the brain itself.
Okay. And let me make sure that I understand. If you've been told that you have high insulin, that should be a signal to you to start working out. You may get the instruction from your doctor that you need to exercise and eat right. And a lot of times those instructions are given without a lot of context around it because they just don't have time. So if you've been told you have high insulin or you're insulin resistant or you're pre-diabetic, any of those things, working out, strength training will help you.
Yes. We'll go through all of the different exercise modalities. They will all help. Mm-hmm. It's so important. The frustrating thing is your doctor probably isn't going to measure your insulin. He's just going to be looking at that blood sugar number. Mm-hmm. So we're going to miss an opportunity ahead of the increase in blood sugar to catch that really early, unless you go in and ask your doctor to measure your insulin levels, fasted insulin.
So you can ask the doctor for that.
Yes.
And they'll probably say, well, insurance doesn't cover it.
It probably costs $3.
Okay. Yes.
Maybe it's more, but it doesn't cost $10,000 to get this done. Right. So you can ask, go ahead and do it. I'll pay the additional. Let me know what it's going to be. They have a list of how much each test costs. I'd like to know my insulin levels. If that's slightly elevated, then we really want to make sure then that we start exercising. And we'll talk about all of the modalities. Start moving your body. Mm-hmm. Right? Doesn't have to be weights. Start moving your body. We have to get that blood sugar under control. We have to reduce insulin resistance.
Okay, so we've talked a lot about strength training. Let's get into aerobic exercise.
Yeah.
Probably most people are familiar with aerobic exercise. Thank you, Jane Fonda. But these are things like swimming.
Right.
Fast walking can be aerobic. You'll tell us about if that falls into the range. Running, biking. Can you tell us about what aerobic exercise or cardio exercise is and the benefits?
Yeah, so aerobic just means with oxygen.
Okay.
All right, so you've got aerobic and anaerobic. Mm-hmm. Aerobic is that low to moderate intensity activity. So right now we're in an aerobic state, right? We're not burning an awful lot of calories, but we're in an aerobic state.
My brain is.
Right, exactly. So because our energy supply is matching our energy demand, we're aerobic. The body can maintain that for a certain amount of time.
Okay.
As we increase the intensity of the work, we start to exceed the capacity of the aerobic system to supply that energy. Mm-hmm. And so that's where the anaerobic activity kicks in.
Okay.
All right.
Okay.
So sprints that are 10 seconds to 2 minutes-ish, those are going to be anaerobic because we need to give your aerobic system time to catch up. Mm-hmm. And then if we stay in moderate activity, now we'll raise up and we'll be able to match that supply essentially indefinitely.
Okay.
Right? So we can keep that going. Mm-hmm. If we take another notch up and we keep getting more and more difficult, we won't be able to match that supply at some point. It will be anaerobic and you won't be able to maintain it very long.
Yeah.
Right? So that's the higher intensity stuff.
So the difference between a marathon and a sprint.
Exactly right.
Okay.
Yeah. So as we start talking about aerobic activity, we've heard a lot about zone 2 exercise and all this sort of stuff. Zone 2 is essentially the level at which you could maintain a conversation, but you wouldn't necessarily want to, right? You'd be able to say sort of a sentence, 3/4 of a sentence, then you might have to stop and take a breath and finish your sentence. So it wouldn't be completely non-impacted, wouldn't sound like this, but you'd be able to do it. Mm-hmm. And so it's sort of a moderate level of exercise. Again, these just have such big impacts on the brain. One of the primary benefits here is the cerebral blood flow. So increasing blood flow to your brain. Now, with that, obviously comes a big increase in delivery of oxygen and glucose to the brain. So just critically important for your brain to increase that blood supply, increase that nutrient delivery to the brain. Huge, huge benefits there. With that increase in stress, you get a release of this substance called VEGF. Vascular endothelial growth factor. What does that mean?
That was my next question.
Right. So what this does, this growth factor, is this is responsible for maintaining the lining of your blood vessels. Okay. So making sure that's super healthy, but then also growth of new blood vessels. So increasing the number, the density of new blood vessels in your brain helps really build in resilience to your brain in that delivery network. Essentially, if we have a denser supply of blood vessels, there's less distance between blood vessels and cells within the brain, right? So now we start to fill in those gaps where we're really able to supply rich supplies of glucose, of oxygen, and all the other nutrients that are coming to the brain, and clear out the waste products. So very, very important factor there in how we actually deliver energy to the brain. Really critical part of cardiovascular fitness there. The other part of it, again, we're going to go back to BDNF. Huge increases in BDNF with cardiovascular fitness. So again, building in resilience into the brain, building the physical structures of the brain, and supplying them with extra nutrients, just such an important part of this specific modality.
So then tell me how aerobic movement helps prevent conditions like Alzheimer's and dementia.
Well, it's all of these exercise modalities, really. So yes, this is one of them. But if you think about layering all of these different exercise modalities, and we think about all of those compounding effects of all these different chemicals that are released, we think about the energy supply, we think about glucose sensitivity, being able to draw more energy into the brain. As we start compounding all of these modalities and these impacts, we can see how we're protecting the brain in numerous ways. One of the things that we're finding about dementia is that it's an energy crisis within the brain, right? And so if we've got an energy crisis in the brain, that's when cells get very, very stressed. When they get stressed, they start creating things like beta amyloid plaques, and they start getting these tau proteins, which are twisted and tangled proteins in the brain. Those are signs that the neurons are under a high degree of stress and they are dying. So essentially the neurons are starving. And when the neurons start getting that degree of stress, right, they start dying off. Whole regions of the brain can die off because they're not getting the energy they need. So we can see now how we're increasing energy supply, which is a huge component, but we're also building in that cognitive reserve. So we're starting to build in redundancy into the brain. So we have more cells, and so we can withstand physical injury and assault to the brain because we can sort of stand to lose a few because we got more coming. We've also created that increased cross-connectivity within the brain, which sort of gives us alternatives. If we start losing areas of the brain and we start seeing cognitive decline, it sort of gives us other ways to access this information and to maintain these functions. So with all of this, the release of BDNF, IGF, growth hormone, testosterone, the VEGF, these are the sort of chemicals that are going to help us protect that brain for the long run. Then as we start looking at other modalities of cardio, we start getting into circuit training, we start getting into high intensity interval training, which is essentially faster paced lifting, more high intensity intervals and things like that. We start building in other unique demands on the brain in terms of multitasking, in terms of coordination, being able to coordinate all these complex movements. Remember what I've got to do next. It's a completely different movement than I've just done. We start building in so much demand on the brain that it's forced to adapt. It's forced to upregulate to meet those new demands. And so we're so much more resistant to cognitive decline.
So then before we move into the interval training, what kinds of activities count as aerobic exercise?
Yeah, so essentially anything where we're moving at a steady state.
Okay.
So we can be walking. Okay, if we're fast walking, I like rucking, for example. So putting a heavy weight on and going for a walk. If you're on your bike, swimming has its own unique benefits. Because of the water, we get this hydrostatic pressure that that actually helps blood flow return to the heart, which increases cerebral blood flow further. It's an unstable environment, so a multi-sensory environment where we've got to coordinate movement in a very unstable space. So we get adaptations there. Hiking, swimming, surfing, all of these factors, anything where you're moving continuously and you're stressing your cardiovascular system, so you're breathing heavy, your heart rate's elevated, all of that counts as aerobic activity.
And we hike often, and I've heard you say that hiking is longevity training.
Oh my God, yeah. Right, hiking especially, so you're out in nature, huge benefits for the brain. Just being in nature, experiencing awe, having dappled sunlight come through, it helps to calm the brain, reduce stress. But then think about as well, you're coming down terrain, different gradients. Maybe there's rocks, maybe there's the slippery portions. So you've got a reactive environment. You have to be looking ahead, planning where you're going to put your feet, reacting to the ground moving under your feet. So there's massive neurological components to being in that kind of environment where you don't quite know what's going to be happening under your feet. You sort of plan your route ahead, and so it's building that sort of hand-eye or hand-foot coordination. But then there's also the proprioception of your feeling under your feet, sort of what's happening. Maybe your foot slips on some loose gravel and you have to sort of catch yourself. You're stepping down off big steps, stepping up big steps. So a ton of leg strength, a ton of balance, coordination, proprioception. It really is one of the better ways to promote longevity.
Let's move on to interval training. For busy people, and in the talk that we gave recently, you mentioned that short bursts of anaerobic interval training can give you rapid brain boosts.
Yeah. So this is where reality hits, right? We'd love to think everyone could be in the gym for 2 hours, but real humans out in the world can't be stuck to that rigid schedule. You might have 15 minutes, right? You've got a 30-minute lunch break. That's when you can get your workout in. If you can get to the gym and do a 15-minute interval program, and this is stuff like on the bike, 20 seconds of sprinting, hard as you can go, 40 seconds rest, and then go again. If you did 2 sets of 6 of those, you'd be in phenomenal shape. Now, you get all those similar benefits. So you get all of the BDNF, you get all of the growth hormone, the IGF, similarly with a circuit style weight training, all those same benefits. But we mentioned it earlier, but you also get these big endorphin releases. So we get our serotonin, our dopamine. So massive boosts in focus and cognitive performance for a short duration after that. But specifically with this, you'll get much bigger increases. So mood, focus, cognitive performance. Great to do over lunch. If you've got meetings in the afternoon, typically we would see that circadian dip in the afternoon around 2:00. And so it would be really important to do if you're going into that afternoon, get an interval session in over lunch, and you're going to see improved performance in the afternoon. The point here is increase the intensity. So go harder, sprint, and take some rest, recover, right? And if you've got 5 minutes, do 5 sprints.
Okay.
And then go, right? All of this is going to have an impact. One of the biggest impacts that you'll see here is insulin sensitivity. And so really great for your metabolic health. That's why it's so important to have this in your program every week is some real high intensity work, because it'll really give you quick improvements in your metabolic health.
So is this something that you would recommend for everyone, or are there any cautions you would give?
Yeah, good question. I think it's really important, just like we talked about with the heavy weight training, that we're really cognizant here of building up to this. Yes, most people can do this. There are going to be exceptions. There are always people who should not do this. Particularly if you've had a stroke and things like that, this probably isn't for you yet.
The high intensity.
Right. And so then it's really important to monitor for that stuff.
But if you've had like a stroke or heart attack or something like that, you should first of all be under doctor supervision. Absolutely.
Right.
And have someone informed helping you through these things.
Yeah, always. always somebody who knows what they're looking for and knows how to prescribe the appropriate level of aerobic exercise.
So tell me what a brain boosting interval session actually looks like.
Yeah. So what it would look like for us, for example, we do 20-20s, right? So 20 seconds on, 20 seconds off. You can increase that rest to get full recovery. But the point is, during the interval, the work phase, you're going as hard as you can. So 10 to 20 seconds, and then you take your rest and you go again. We do 5 to 6 of those. We rest for 2 minutes and then we do them again. All right. So in total there, you've done about 6 minutes of work, but you're going to get huge benefits metabolically, and all of the catecholamine mix in your brain from the norepinephrine, the dopamine, the BDNF. You'll just get incredible increases there.
And we've done these intervals on bikes, we've ran hills, we've done stair workouts.
Yep. The skiers.
Yeah, the skiers.
Yeah.
Rowers, the aggressive bike.
Yeah.
Yeah. And jump rope is a good one.
Jump rope's great. Yeah. So
Yeah.
all of these modalities are great. Just to translate for those who don't know, the aggressive bike is the assault bike.
It's aggressive.
Right. It is aggressive. And so, yeah, all of those modalities, anything that's going to allow you to ramp up your intensity really quick. You don't want, if you're standing on the treadmill and you're trying to increase the speed, like in between intervals, and you're trying to increase and decrease, it's going to take so long to get up there that you're actually not going to do your interval.
Yeah.
So something that allows you to ramp up real quick, and then stop real quick.
Yes. Remember, you used to have us do dead treadmill sprints.
Yes.
Luckily, we have not had a good treadmill for that in recent years.
Right.
So, because that was horrible. Okay. So talk to me about connection, because I've heard you say that connection is as important as exercise for brain health.
Yeah, it genuinely is. If we look at the work of the Blue Zones Project, for example, one of their big findings was that if you are morbidly obese and lonely, it is more beneficial for your longevity to get into a very close community and make some meaningful friendships and connections than it is to lose the weight. So I think what's important there is to understand the mechanisms by which this happens. Loneliness is a massive driver of inflammation in the body. Massive driver of stress hormones, and this whole mix that boosts inflammation. So when we get into a group, we get this cross connectivity within the brain. We're having to pull memories. We're having to listen to what somebody's saying and formulate our response. So we're creating a lot of work for the brain to actually increase those connections. So we're building that cognitive reserve again. We're seeing reductions in inflammation. We produce all of these anti-inflammatory cytokines in the body, where the chemicals that we release into the body to reduce inflammation. So huge protection for the brain there, because it's very, very sensitive to any sort of inflammatory response in the brain. So we've got to do whatever we can to reduce that impact. I'll rewind a little bit. When we're lifting, we get a specific kind of anti-inflammatory cytokine that's released called myokines, only released from muscles. And when we contract the muscles, these get released and create a profound decrease in inflammatory factors. So another benefit of strength training to add on there.
There's been a lot of information here. As a recovering perfectionist, I can easily be immobilized by the overwhelm, by all of the things that we should be doing and not enough time to do these things. And then I'll come to you and say, oh, I didn't have enough time to do a 2-hour workout, or I didn't have the perfect protocol. Is this even worth it? And then it's very frequently you'll say, Michelle, let's put this in perspective.
Right. Yeah. So I think if we look at, okay, how do we break down our week then? So lifting is important, and circuit training is important, and high intensity intervals is important. And we've got to get 12 hours of zone 2 cardio in, and all these messages that we're getting. Look, perfection is going to kill you here. what we need to do, if you're super, super busy and over capacity, if you can get 2 circuit style weight training sessions in a week, you're going to get benefits. It's going to give you some cardio. It's going to give you the BDNF. It's going to stress your muscular system and your brain's energy systems. It's going to give you the releases in growth hormones and testosterone and IGF-1. So that is going to be a great place to start. If we look at what's ideal, if you could get a couple of continuous cardio sessions in, let's say we get 2 of those in, we get 2 lifts and we get an interval session, right? There's 5 days a week. We're getting a mix of all of these different modalities, and it's going to be beneficial. You're going to stack the benefits. Don't worry about being perfect. Use the time that you've got. If it's short, do some high intensity intervals, do a circuit. If you've got more time, do some cardio and some weights. Just give yourself a mix of these different modalities throughout the week, and you'll get those compounding benefits.
And so then what is the simplest starting point for someone overwhelmed?
If you're really overwhelmed, start going for a walk every day.
Mm-hmm.
I mean, literally just get up and walk for 20 minutes. That's been the thing for us. And it's especially powerful if you put that after dinner.
Mm-hmm.
So if you walk after you eat, you really control glucose spikes, you increase insulin sensitivity. And so you get some of those metabolic benefits. And I think those are some of the most important to start out with. So it'd be super simple to just start with 20 minutes of walking and just do that every other day. And you'll start to gain some traction and get some benefits. Mm-hmm. And then, if you start putting that in every day, and then you go to the gym and so on and so forth. But start with some walking and start with 20 minutes and build it up from that.
I think it would be good to hear about some people that you've seen have benefits, mm-hmm. like brain health benefits from increased exercise.
Yeah, that's been a byproduct of with all of our mm-hmm. clients. We work with people who are 60 and up essentially. And one of the biggest things they've noticed is their mental clarity. Yes, we've got the weight loss. Yes, we've got the increased muscle mass, but a lot of we work with a lot of executives, mm-hmm. right? They're in positions where they're making a lot of decisions. They are cognitive athletes, and they're talking about how dialed in they are, mm-hmm. how they're able to focus, how just switched on they feel, mm-hmm. right? They feel like their brain is really firing. Mm-hmm. And this is coming after 3 to 6 months of working out, mm-hmm. right? And when they really start to notice their brain mm-hmm. coming back online. So that's been profound. Really, really great benefit of what we're doing.
So as we wrap up then, what are 3 things that someone can do today mm-hmm. to get better brain health?
Number 1, stop drinking. Number one, stop drinking.
What are you looking at me? I have like 1 a month.
So number 1, stop drinking. Number 2, circuit style weight training. 15 minutes. If you get in and do a 15-minute lift, you'll get all of these benefits. And number 3, take a walk after dinner. Mm-hmm. Right? Let's really work on that metabolic health. Some bonus things that you can do over the next few months. Those are 3 things that today you can walk out your door and do. Talk to your doc about getting tested. We need to test your insulin, your A1C. We need to know what your ApoB markers are. We need to get a really good understanding of your metabolic health and your lipid profile, so that we can be aggressive in making sure that blood supply to your brain is really optimized. Requesting a coronary calcium score. For some people, that's going to be prohibitively expensive. It's around $250. For other people, it's going to be accessible. We would like that to be democratized to everybody, mm-hmm. but really start advocating that your doctor do some of these preventative studies so that we can get ahead of it and be early on these. Even people with a very, very low coronary calcium score, maybe it's a 1 on a scale of 4,000. It's not a 0. Remember, these small plaques in your coronary vessels are large plaques relatively in your blood vessels of your brain. So be very aggressive with making sure that that system is taken care of.
Mm-hmm. And this is not meant to be a message to scare you, but a message of hope.
Absolutely.
These are all things we can
absolutely. Like we barely spoke about the medical factors today. We barely spoke about genetics. Everything we've talked about today is entirely under your control. Massive, massive benefits for the brain just on doing things that you can go out the door and do today. So yes, there are some medical factors. Yes, there are some genetic factors, but don't let that dictate your outcomes, right? Those are risk factors. You can eliminate them by changing your lifestyle. And that's what we're all about. It's like, why are we worried about the stuff we can't impact? There's so much we can do. There's so many things that you can go out the door and do to impact your health today that really your future and the future of your brain, your longevity is entirely under your control.
And if you haven't heard all of our previous episodes, we would suggest that you go back and listen.
Right.
But if you're particularly interested in brain health, there are a few that we'll point out. The episode that we did with Dr. Dennis Hughes, which is on proactive medicine for brain health. We did an episode with Dr. Melissa Lim. We didn't really get into sleep here, but sleep is so important for brain health. That's a whole other episode. So listen to that one. Also, we did one with Dr. David Petrino on cognitive performance.
Yep.
So those are all episodes, and we'll put those in the show notes to go back and listen to if you haven't heard them.
Yeah, and then we've got one coming up with Dr. Sherry Ma, where we're going to talk about sleep and performance and brain health. So that it deserves its own. It was our own talk. We did a whole talk on sleep and brain health. It's probably the pillar of brain health that we like to build around.
Sleep.
Sleep, yeah. And so we'll certainly cover that in upcoming episodes.
Jeremy, thank you. This has been wonderful today. Thank you for letting me interview you.
Thanks for coming from behind the camera and stepping up as the co-host today.
Yes, it's great. Been great fun. Thank you.
All right.
That was a fantastic conversation between Michelle and I on building a healthy brain. Here are 3 key takeaways from today's episode. Number 1, stop drinking. Alcohol negatively affects brain health and neurochemistry. Removing it is one of the most powerful first steps you can take. Number 2, do 15 minutes of circuit-style weight training. Even short sessions provide massive cognitive and metabolic benefits, from boosting BDNF to improving insulin sensitivity. Number 3, take a walk after dinner. This simple habit helps regulate blood sugar, enhance insulin sensitivity, and support both metabolic and brain health. If today's discussion resonated with you and you're looking for ways to integrate early detection, personalized health strategies, and strength-based longevity into your own life, we would love to help. At Vitality Collective, we've built these principles into a comprehensive system designed to optimize health and performance at any stage of life. If you're ready to take action and see how this approach could work for you, visit www.vitality-collective.com to learn more. Thanks for listening, and we'll see you next time.